Hi folks, Mr. Keeley here with an example of a Newton's first law project. My project is going to be the option we call option 3, or not the bubble level, not the crash, but instead something from my life. You probably know I've got little kids and they're always playing with toys. This one I really liked, it struck me as very cool. This guy right here. I'm going to go ahead and show you what it does and then describe its motion using the vocab words we have. All right, here we go. I'm going to set the toy down so that its position is on the left side of your screen. Alright, the toy changed its position. In between here and here it had a velocity. Subjectively I would call it a pretty low velocity, right? It didn't go from here to here very fast. But there must have been acceleration both here when the toy was speeding up to start moving, and also acceleration here when the toy stopped moving. There's an interesting part of its motion too where it's got sort of a jumpy, bouncy bit. I'm not sure if you can see it from there, but it jumps into the air, right? And I'm looking, there's times when the tips of its feet just come off the ground. So I know it must be accelerating upward a little bit and then downward, upward a little bit and then downward. There's the little bird. And if I was to draw its motion, I would say the bird goes like this. It jumps up in the air, lands over here somewhere, and then it jumps up in the air and lands over here again. I want to pick a few different points to make free body diagrams. I'm going to pick these 2 points. The first point I'm going to pick is right here on the ground when the bird is starting to jump. And the second point I'm going to pick is right here in the air at the top of the bird's jump. Alright, let's sketch those out. The first free body diagram is going to look like this. Now I'm making a free body diagram. There's rules I got to follow, so let's get it right. First, I'm only going to draw the bird, nothing else in its environment, just the bird. I'm going to draw the bird as a square. That is totally fine in a free body diagram. Second, I'm going to draw the forces acting on the bird as arrows coming out of the center of the bird. Well, the bird's on Earth, so there's a force that's always acting on things on Earth or on any other planet, and that force is gravity. But the bird wasn't accelerating down through the table, something was holding it up. So I know that there's a force that the table is putting on the bird called a normal force. Just like that. And I'm going to label that guy over here. The normal force is over here. Now, I also know that there must have been some other force. And I know that because the bird moves, jumps over and moves. Well, that force came when I wound the bird up. It's a spring force. And that's a good example of Newton's third law, because the bird pushed back on the table this way. The springs in its legs push back on the table, so the table pushes up on the bird. So I'm going to make that force drawn right here and show it's a force like that. I'll call it Fs for force of the spring, and that is my free body diagram for when the bird is about to jump. You can see it's about to leave the table just like that. Let's make another free body diagram for when the bird is in the air, up here. The bird's in the air. Once again, it's a free body diagram. I'm going to draw it with just a square to show the bird. The bird is on Earth. Earth is pulling down on it with the force of gravity. So I got force of gravity. Bird's not touching the table, so the table's not pushing back on it. Nothing else is touching the bird. There might be a tiny little bit of friction from the bird moving through the air. Would be resisting direction of motion. So I might put a little tiny friction arrow, the smallest one I can draw right there. Wouldn't be much friction, but nothing else is acting on the bird to slow it down. So that's my free body diagram for when the bird is in the air. My bird demonstrates Newton's laws in a couple of ways. First, it demonstrates Newton's first law because until an unbalanced force acts on it, the bird doesn't move. You have to wind it up, put some energy into it so it can apply a force that then causes it to move. My bird demonstrates Newton's second law because it's a large mass and a small force, so it doesn't accelerate very much. Even when it's going full speed, there's not a lot of acceleration there because it's relatively heavy and that force is relatively small. And my bird demonstrates Newton's third law because the only way it works at all is by pushing off the table. If the bird kicks down and there's nothing to push against, the bird doesn't go anywhere. But when the bird can push down and get the equal and opposite force of the table pushing back, then it goes somewhere. So in conclusion, this bird demonstrates Newton's three laws.